in this conversation, we'll see that how you just create and configure a classic load balancer. Okay. So over here, first of all, before I can just deploy the load balancer, I have to just configure these security groups. Now you may ask this question, what's the purpose of the groups, or what's the purpose of the security group in this entire configuration? See, if you see the ELB configuration, let me just go with the configuration part. Now what happens is, let's imagine this is my these are my users. These are my users. And they are sending the traffic to the load balancer. Fine. And the load balancer is forwarding the traffic to a group of EC2 instances. Fine. Now, as you can see, the load balancer is exposed to the internet. It is exposed to the internet. So it's very, very important. It's extremely important that I just apply a firewall that's called the security group to the load balancer to ensure that it's not being exposed to some unwanted traffic. So let me just draw it again, because I want to just show you the configuration part. So what I'm gonna do is that, let me just draw this stuff again. So these are my users, and the users are sending the traffic to the load balancer. Fine. So this is my load balancer, and the load balancer is now forwarding the traffic to, let's imagine these are 10 EC2 instances. These are my 10 EC2 instances. These are my 10 instances that are there. Fine. These are my 10 instances. Now, the thing is, it's extremely important that you understand that how exactly you just formulate and you just configure the security group of the load balancer. See, first of all, let's understand this thing. We have to just create a new security group of the load balancer. Let's name it as ELB-SG. Okay, so this is the group that I will be assigning to the load balancer. Now for these 10 instances, I will have a common security group, that is EC2-SG. So these are the two groups that I'll be using in this entire config to protect my applications and servers. Okay, now the question is that how exactly you will just structure and formulate the inbound and the outbound rules. Let's do that. Let's start with the ELB-SG. Now let's imagine that we are sitting on the top of the load balancer. We are sitting on the top of the load balancer. Now for us, what should be the incoming traffic? The incoming traffic should come from the external users on the internet. So for example, this load balancer is receiving the web traffic, that is HTTP/HTTPS. Okay, so let me just write down this once again. So these are my users. So what should be the incoming traffic for the load balancer? The incoming traffic for the load balancer should be the HTTP/HTTPS coming from anywhere, 0.0.0.0/0. Fine. 0.0.0.0.0/0. This means it's coming from any external user on the internet. So this is the inbound rule of the ELB-SG. What about the outgoing? The outgoing will say that the HTTP/HTTPS HTTPS will be sent to EC2-HA. What is that? That's the EC2-HA. So the thing is that instead of sending out the outgoing traffic to each instance individually, because in that case you have to configure 10 different outbound rules, we're saying we create only one rule that will be sent across to a group of instances. That's the EC2-HA. I'll show you this configuration so that you understand this in a much better way. Right now, you just try to understand the concepts. Fine. Now, on the other hand, let's do one thing. Let's formulate and define the rules in the EC2-HA. EC2-HA. Now for EC2-HA, the group that will be assigned to all the 10 instances running behind the scenes, what should be the incoming traffic? So let's imagine that if we are sitting on the top of the instances, or we are the instances, for us, the incoming web traffic is coming from where? From the load balancer. The incoming web traffic is coming from where? From the load balancer. So I would say that the HTTP/HTTPS is coming from the ELB-HA. So I will say that we will receive the traffic from the load balancers group, which is being assigned to the load balancer. Fine. So I'm saying the incoming HTTP and the HTTPS traffic should come from the ELB-HA. Fine. Then let's go to the outgoing. So what should be the outgoing traffic? The outgoing HTTP/HTTPS should be sent directly to the users. So this thing you have to remember, the load balancer is only for the incoming traffic. The outgoing response traffic should be sent from the instances to the users directly. Okay, so what's about the outgoing traffic? The outgoing traffic should be sent to anywhere, which is 0.0.0.0/0. So I hope that we understood the entire crux of this conversation. We have to make sure that the traffic is coming from the exact source and going to the exact destination. And we have to ensure that we don't compromise in terms of security. Fine. Now let's do one thing. Let's go ahead and start formulating or structuring this these two different groups. So I'm going to go back to my AWS Dynamic console. So let me just minimize the screen. And here we are. Let's do one thing. Let's go to the EC2. And I will just create two different security groups. So I already have a running instance. So let me just see if I can stop it. I think this is the same instance I initiated in the previous session, because I also have some sessions going in the weekends. I go to these services right now. Okay, not services. We are on the EC2 dashboard under the region of Mumbai. We are there. Fine. So let's do one thing. Let's click on these security groups under network and security on the left hand side. Now this entire thing is called the navigation pane. So in this navigation pane, I just go to the security groups under network and security under the navigation pane, and I click on create security group. Now before that, let's do one thing. If I can just delete the duplicate one, I can just do that. Let me just see if I can just get rid of the duplicate groups. Let me just give me a few seconds over here. Let me just get rid of them, because they will just allow some kind of duplication, which I don't want. Okay, so let's do one thing. Let's create two different groups. So I click on create security group right now, and the very first thing is I'll just do is that I will just assign a name to it. Let's name it as ELB-HA, and in the descriptions type in this. Let's type in once again. This security group will be assigned to our load balancer. Fine. And I choose my VPC, the virtual private cloud. I will not formulate any inbound and outbound rules right as of now, and straight away go to this create option and click create. Done. Now I click on create security group once again. Let's do that. And I just create another group real quick. Let's name it as EC2-HA. And in the descriptions, type in this security group will be assigned to all the EC2 instances that will be registered to our load balancer. Fine. So this will be assigned to instances that would be this security group will be assigned to all the instances that would be registered to our load balancer. So I choose the same VPC without configuring any inbound and outbound rules, and just go ahead and click on create. Done. So as of now, I've created two different groups. This is my, let me just assign them the tag ELB-HA, and for this one, this is the EC2-HA. Fine. Now let's now start defining the inbound and the outbound rules of the ELB-HA, the group that will be assigned to my load balancer. I hit edit. I would say let's allow the HTTP from anywhere. So I say HTTP traffic from the end users. Similarly, I just include the HTTPS traffic from anywhere. So I would say let's allow the HTTPS traffic from end users from anywhere. To click save. Then I go to outbound. I will hit edit. I will say that let's allow the HTTP to the custom source. And what a custom source? EC2-HA. Let me just type that over here. Can you see that? EC2-HA. So I'm saying that I would like to just divert the entire web traffic. I want to forward it to the group of instances. That's the EC2-HA. Then let's type in HTTP traffic to be forwarded to EC2 instances, right? Done. So I'm saying that the HTTP traffic will be sent to the EC2 instances. Fine. Similarly, I'll include the HTTPS traffic. Let's choose the HTTPS to the custom source. Okay, I choose the custom source. Then I will say let's allow the HTTPS traffic. Fine. And then what we'll choose over here, EC2-HA. Fine. So are you able to relate the same concept with this configuration? Over here, I'm saying that the load balancer will get the traffic from any source, from any end user, but the same traffic will be forwarded or will be sent across to the instances or the instance group behind the scenes. Click save. Fine. If I don't do that, if I don't assign this group, then in that case I have to create 10 different rules. For 10 instances, I have to specify the 10 different individual private IP addresses as a destination. So this will bring down the amount of configuration that I need. Fine. Now I just go to the EC2-SG and start configuring it. I go to inbound and hit edit, and I will say, because the instance will get the traffic from the load balancer, I would say let's choose the HTTP traffic from the custom source, and the custom source would be the ELB-SG. Let me just type that in, and I just type in the HTTP traffic, HTTP, or I'd say incoming HTTP traffic from ELB or the Elastic Load Balancer. Incoming HTTP traffic from the load balancer. Similarly, I choose the HTTPS. So I say incoming HTTPS traffic coming from the Elastic Load Balancer, and the source will be the custom, that's the ELB-SG. Let me just type that in for you, and here we go, ELB-SG. Click save. Done. So we're saying that the entire web traffic should come from the load balancers group or the load balancer. Then what about the outbound? So if we hit edit, we remove the all traffic default rule, add a rule, and we'll say that the HTTP response should be sent to any user. So HTTP, let's type in HTTP response to end users. Fine. And similarly, I just include the HTTPS traffic to anywhere. So HTTPS traffic to the end users, response to the end users, I would say that. Click save. Fine. So I hope that this is clear. We have to create and configure these rules to ensure that you can just go ahead and apply these groups, these security groups to the load balancers and or the load balancer or the instances wants to start deploying them. This is very, very important, extremely important. Okay, because this enhances the security of the load balancer and the instances running behind the scenes. So it's extremely important that you configure it. Now the next thing that you have to configure, which is optional, I'm not saying it is important. The next thing that you may configure, it's optional, is the configuration of something called the SSL certificate, or I would say it is, let me show you once again, TLS certificate. So it is the SSL/TLS certificate. So how this works for you, SSL/TLS certificate. So what's the purpose of it and why you need it? See, let's imagine that this is a user, okay, and this is your banking server for transaction, right? Now the thing is that whenever user is making any transaction, it's very important that this connection is entirely closed or encrypted. It's entirely closed and encrypted. For example, this person is Tom. Now the thing is that if you don't encrypt it, anyone can pose as Tom and get into the stream and make transactions. Okay, so we want our servers, our websites to be secure enough so that the communication, the connection established from the user to our servers, that entire channel is encrypted. So what you do is that to your servers or the websites, you just upload something called the SSL/TLS certificate. Okay, this makes your website or the front-end web servers secure for the front-end users. You may have seen this thing almost on all the secure websites. There's a symbol like this, a lock symbol, right? This means that this is secure. If I just click on this, it says this is secure. I can just click on show certificate, and this is the certificate, the SSL/TCP certificate being issued by Amazon. So this means that you can see over here, secure socket layer SSL, right? This is the certificate. This certificate is issued to ensure that the channel, the connection established from my end to this website is encrypted and it's being kept secure. Fine. So to make a website secure behind the scenes, you may upload these certificates. Now there are two ways how to upload the certificates. Either you upload that to the instances directly, you upload that to the backend instances, because ultimately all the websites, all the applications and services are running upon instances. But the thing is that if we have the load balancer running in the front end, why can't we upload the same certificate to the load balancer? Now that process is called the SSL termination. What is that? That's called the SSL termination. Now what happens in the SSL termination is that let's imagine these are my users. Let's imagine, fine, and they will send across their request to the Elastic Load Balancer. Fine. Now what we do is that we upload the SSL/TLS certificate to the load balancer. Now the load balancer is sending all the traffic to these instances. For example, these may be 50 instances. Instead of uploading the certificate to each and every instance, you upload the certificate to the front end load balancer. Now what happens is the load balancer will encrypt this front end connection. This front end connection would be encrypted. The front end connection would be encrypted, purely encrypted. Then the load balancer will then decrypt the traffic and send it across to the instances. So it will first of all encrypt the connection, the front end connection, and then it will just decrypt the backend traffic and forward it. It will perform it from the decryption of the backend connection, so that the decrypted traffic is being sent across to the instances behind the scenes. This process is called the SSL termination. So you upload the SSL/TLS certificate for the load balancer. Okay. Now to issue a certificate, you have to have a domain. You have to have a domain to issue a certificate. So I need to make sure this is the same page where my domain is being issued. So let me just go to the root 53, and if I need to just confirm that I have to sign in to the same account whereby the domain is there. Okay, this is not the one. So I just show you a small prototype that how you issue a certificate. Okay, basically you have to have a domain. That's it. You have to have a domain. The main service that you use to issue a certificate is this one. That is the certificate manager, which you can find under the security, identity, and compliance, where you have the IAM. So if you just go downwards, you will see the certificate manager. This will help you to issue the free SSL/TLS certificates for your domains. I go over there. Now I just show you the process. I can't show you the entire uploading process because the thing is that I have the domain with AWS, but for some reason it's not able to validate that certificate. So let's do one thing. I just go back to the main dashboard. I just go to the main page of AWS Certificate Manager, and you can see the description that this service makes it easy to provision, manage, deploy, and renew SSL/TLS certificates on the platform. I just go to the provision certificates on the left hand side. Get started. I just request a public certificate. Click on request a certificate. Then I specify the domain. For example, I have a domain learn AWS the hard way.com. Fine. So I'm just requesting to issue a SSL/TLS certificate for this domain. I can also get the certificate issued for my subdomains. Just click on add another name to the certificate. I just include a wildcard. It's an asterisk, star, then a dot. Then I specify my domain. So this wildcard will include the subdomains. For example, www.learnawsthehardway.com. Okay, learnawsthehardway.com. So asterisk dot will include the subdomains. So I click on next over here. Now this is where I get stuck because I think there's some issue with my domain. I can go with the DNS validation or the email validation. So if I, for example, go with email validation, I should receive an email to authorize this certificate. I click review, click confirm a request, and click continue. Now, basically, it should send across an email to me. I think there's some issue behind the scenes. My email is not being recognized as the administrator. Fine. So in that case, I'm not able to receive the emails. The one step that is missing that I can't show you right now is that I receive the email with a link. I click on the link and I just click on I approve. That's it. I approve the certificate. You can see over here. Validation not complete. The status of the certificate request is pending validation. Further action is needed to validate and approve the certificate. It is just that I am supposed to receive a link. I click on that and I approve the certificate. I approve the certificate. After that, the status will be issued or active. That's it. Okay. So that's how you can make use of the AWS Certificate Manager to issue the free SSL/TLS certificates that you may upload later on to the load balancer. Fine. So these are the two prerequisites. This is the optional stuff. This is not mandatory. This is only needed if you allow the HTTPS or the SSL traffic in the front end. For example, this website is secure. So it is HTTPS. So if you include HTTPS in the front end or SSL, so this is very important stuff. So if you, in the front end, let me just go back to the same note. So if I include the HTTPS or SSL traffic at the front end, then I need this certificate. If I don't include these two different protocols or any one of these two, I don't need the certificate at all. It's not mandatory. Okay. Now, I go to the services, open my EC2, and start showing you the process to deploy the load balancer. So I go to the load balancers on the left-hand side. And one thing you have to understand, the load balancer is a region-specific resource. The load balancer will work upon the multiple AZs in a single region. I go ahead and click on Create Load Balancer on the top left-hand corner. And you can see that these are different types of load balancers that I can deploy: application, network, and classic. Now, what's the difference? See, I start with the classic one. The classic load balancer is the one that works at two layers: transport and the application layer. This is a very simple load balancer with no advanced routing mechanisms. It's a simple load balancer with no advanced routing capabilities. It's a previous generation. Basically, they say that you don't use it. You use any of these two different load balancers, but still it's being used. In the exam, you get few questions from the classic load balancer configuration. Then we have the application load balancer. Now, this is much more advanced than classic. It works only at layer 7, which means it entertains HTTP and HTTPS traffic. Now, this is mainly used for the content-based routing. You can just route the traffic to the IP addresses, ports, containers, microservices. Microservices means that on a single instance, you have different services running upon it. So you can divert the traffic based upon the ports, the content, and the services running upon the instances. So this is much more advanced. Network load balancer is the newest type of load balancer, which is needed in case if you need the ultra high performance. This is quite fast, and it has the ability to handle millions of requests per second while maintaining the ultra low latencies. It's very fast. It is the costliest of all the load balancers. It's used in the cases where your application should be handling or should be taking care of millions of requests coming per second. Basically, it's been used by the e-commerce platforms. Fine. And also, you can assign a static elastic IP to this load balancer. We'll discuss that afterwards. But the main thing that you have to understand is that the network load balancer is used in the cases where you are looking for the ultra high performance, and the same load balancer will need to take care of millions of requests per second. Okay. Now, I deploy any load balancer. I will deploy any load balancer. It doesn't make any difference over here. Reason being, because right now we have to understand the basic stuff, the concepts. I'll deploy the classic one, and afterwards I'll deploy the application one. Network load balancer is not the part of the curriculum as of now. Why I'm starting with the classic one? Because in the exam, there are few questions that come from this load balancer. And if I show you the deployment of the classic load balancer, then deploying the application is an easy piece of cake. Classic is tougher. Classic load balancer config is of higher level as compared to the application. So if you understand classic, understanding the application is very, very easy because the configuration is almost the same. Very few differences. I think not more than 5% or 10% maximum. So I go with the classic load balancer, click on create. So I just click create on the classic load balancer. Now, after that, once I click create, the next thing I will do is that I will just assign a name to it. So the name, I'll just name it as Mumbai ELB. Okay. I just picked my VPC where this load balancer will be running. Generally, the load balancer that you create, those load balancers are the public-facing load balancers or the external load balancers. The public-facing load balancers or the external load balancers are the one that they are exposed to the external users, to the internet. Now, in very few cases, you can make a load balancer internal in nature. In that case, that internal load balancer will just take care of the internal routing. That's it. It's not intended to receive any request or traffic from the internet. So I'm gonna uncheck it. I will uncheck it to make it as to have this load balancer act as the public facing load balancer. Now I just go to the enable advanced VPC configuration, enable advanced VPC configuration, check mark this option. And once I check mark this option, I have to choose at least 2 different subnets in different AZs to provide higher availability for your load balancer. So it is saying that you choose 2 different subnets. You choose 2 different subnets across 2 different zones, so that the reason being, or the purpose is that you can achieve higher availability. If one of the AZs goes down, you can start using the second one. So under actions, I click on the plus sign to choose both the subnets that are associated to 2 different availability zones. That are associated to 2 different availability zones. The last config is the listener configuration. Now, listener configuration is a process of listening to the request. The load balancer protocol and port, it determines my front end traffic, and instance protocol and port defines my back end traffic. So the front end is a connection that's coming from the users to the load balancer, and the back end traffic is the one that's being sent or forwarded from the load balancer towards the backend instances. So for simplicity, so the thing is that since we're using Classic, we can choose any of these protocols: HTTP, HTTPS, TCP, or SSL at the front end and at the back end. For simplicity, I'll go with the HTTP at the front end or HTTPS at the back end. If I choose HTTPS or SSL at the front end, then on the 4th step, I have to upload the SSL/TLS certificate. But as of now, I just make this config simple, and I'll only include HTTP at the front end and HTTP at the back end. I click on next assign security groups. Now I'll just pick the same group that we have pre-configured, which is the ELB-HE, this one. Okay. Click on next configure security settings. Now on the 3rd step, this is where we have to upload the certificate. Since we haven't included the HTTPS or the SSL protocol for the front-end connection, we don't have to upload it. We click on next configure health check. Now this is where we configure the basic health check options. The main thing you have to look into is the protocol, the port. By default, we choose the HTTP protocol over port 80 as the health check traffic. You can change it if you want. The ping path is the default web page of the website or the web application or the web server running upon the backend instances. So in my case, it would be a /. Okay. In the advanced details, it's a timer. These are the timer values. These are the seconds that work for your health checks. The main thing that you have to look into is the interval. That's 30 seconds. This means that after every 30 seconds, the health check will be repeated. It's the amount of time between the health checks. So minimum is 5 seconds and maximum you can go up to 300 seconds. So you can manipulate this default interval if you want. Rest you don't have to go by that. I click on next add instances. No, I don't have any instances right now. I will just deploy the instances afterwards. I'm gonna deploy the instances afterwards. We'll just do that afterwards. And these are the two different options: cross-zone load balancing and connection training. We discussed that. Cross-zone load balancing means that the instance or every instance will get the equal amount of traffic from the load balancer. Okay, so the load balancer will perform the equal distribution of the traffic across all the instances. Connection training, this means that if an instance is unhealthy, before taking that instance out of service, it ensures that the existing connections are being taken care of, and in the meantime, the new connections should be sent to the other healthy instance. So by default, we have 300 seconds. Now we click on next add tags. We can just add a tag value, but this is optional. Click review and create. We can review any of these configuration parameters if you want, or else we click create and a load balancer is created. Now the thing is that it will take some time for the load balancer to become active. In the meantime, I just deploy two different instances using a script. That script will install the Apache PHP web application upon the instances. So I go to the instances right now, and also I'll give you a copy of that script afterwards so that you can just have a look upon that. Just give me a few seconds. Let me just fetch the script for you. Okay, so this is the script. I share the script with all of you. I copy the script and I show you that how you use it. I click on launch instance right now. Now this script will work on this AMI only. That's the Amazon Linux AMI, this one. Okay, it chooses, click select. We go with the same t.micro as my instance type. Click next configure instance details. Now I choose my default VPC, but this time I choose AP South 1A. I go to advanced details and copy and paste this script. Now this script will install the Apache PHP web application upon the instances. Okay, so you have to make sure that you just copy and paste it properly. Then click on next add storage, next add tags. I just assign a key value, name, key as name, and value as instance A. Instance A. We click on next configure, security group. Now I just pick the EC2-HE that we have pre-configured. We click on review and launch, continue, launch. I can choose any of the key pairs and launch my instance. Similarly, I launch a duplicate instance with the same AMI, same instance type. This time I'll pick a different AZ, AP South 1B. Go to advanced details and paste the script, the same script. Click on next add storage, add tags. I will just name it as, let me just name it as my instance B. We click on next configure security group. Just pick the same group, that's the EC2-HE. Click on review and launch, continue, launch, choose a key pair and launch my instance. Now, I'll show you exactly that what output you will get. So I just manipulate my instance security group and I just allow the HTTP just for this example from anywhere so that we can test whether the web application we are running upon the instance it's working or not. So I go back to the instances right now. I choose my instance A, copy its public IP, and paste it on my browser. So let's see if I get something. Can you see that? So if I browse this instance using its public IP, it shows the instance ID of the instance and the availability zone where that instance is running. Where that instance is running. Fine. So that's it. So I can remove this rule because we have tested it out. Okay, we can just remove it if we want that. Or okay, I'm sorry. I think that's fine. We can, yeah. So let me just remove these things. We don't need that anyhow. Fine. So the HTTP is coming from the load balancer, and HTTP is from the same stuff, from the same load balancer, right? So that's it. I think we have to. I have to. Okay, I just leave it as it is. I'll not change it as of now. Fine. Now, what I'll do is that I go to my load balancers right now on the left side. I click on load balancers. I go to instances right now and click on edit instances. I add A and B, hit save. Now, as you can see that these instances are showing auto service. If I just hit refresh, within a few seconds, they'll become in service because right now these instances are in the process of registering themselves to the load balancer. So we have to wait for a few seconds. Okay, here we go. So as you can see that our instances are in service. Now, if I just go to description, and this is the DNS name of the load balancer. If I just copy this DNS name and I paste it over here, I can just, let me just browse it once again. Now, can you see that it is sending my traffic to the instance in AP South 1B. Hit refresh, it will send it to the instance in AP South 1A. Hit refresh, another instance in AP South 1B. Refresh, the instance in AP South 1A. If I copy and paste the link for you on the chat window, even you can browse it on your own. Okay. Now, in the real-time situation, I should be linking this load balancer's DNS name with my own domain, for example, xyz.com. Fine. So we use a service called Route53 for that. That we'll discuss maybe this week or the next week. So this is how we're going to test our load balancer. This is how we're going to test our load balancer. So this is about the stuff. This is how we do that. Now there's one last option that we're going to discuss over here. That's called the stickiness. Stickiness means that you can stick the user session, because right now, if you just go to the link and you just hit refresh, you will be sent across to multiple instances. So it's using the round robin algorithm. The next time you come in, you may get to a new instance. But the thing is that you may need to override this default behavior by using the concept called stickiness. So what happens in the stickiness is, let me just discuss with you. So let me just okay, so let me just discuss with you the stuff. Give me a few seconds over here. So over here, the next thing we'll discuss with you is the stickiness. So in the stickiness, what happens is, let's try it out once again. So in the stickiness, you intentionally stick the user session to a single instance. For example, if this is my user, he's being sent to a load balancer. He's being sent to a load balancer. And load balancer has two instances, A and B. Now, if for the very first time, if his request is being sent to the B, and if the stickiness is checked marked, the load balancer will save a cookie that is AWS ELB, which consists of a timer value, which is the 60 seconds, for example, in our case. So it's a timer value. So for next 60 seconds, if the same user comes in again, he will be sent to the same instance. This is called the stickiness. We intentionally stick the user's session to only one instance for a predefined time frame. Right? So if the user comes back in, the load balancer will check the cookie settings, and for next 60 seconds, the user's request will be sent to only one instance. This is mainly used in the cases where maybe you're running some payment application spawn instances. You want the payment transitions, payments or the transactions to be completed before the user's session may land to a different instance. Or maybe you're running an e-commerce platform and you want the transaction to be completed. The transaction to be completed before users' requests are being sent to the other server. So that's the stickiness. Now, how you enable it? By default, it's disabled. You hit edit. You just go with the load balancer generated cookie stickiness. Or if you have created a cookie when you have created your application, you can go with this one. I go with the load balancer generated cookie stickiness and define the expiration period of 60 seconds. Hit save. Now, you guys, if you just go to the same link, hit refresh again and again, you will see that eventually this will not change. This will not change now because the stickiness has kicked in, and you just hit refresh again and again, again and again. You will not go to any other server, any other instance for next 60 seconds. That's the main usage of stickiness. Then, if you just go to the this thing, access logs, you can just configure the access logs, enable it, and have these logs delivered at the interval of 60 minutes or 5 minutes. So there are two intervals, 5 minutes or 1 hour. So these logs can be saved to one of the S3 buckets in the same region where the load balancer is, so that you can just analyze the request made to the load balancer. It's mainly used for the troubleshooting or analyze the access patterns. Fine. That being said, this completes the configuration of the classic load balancer. So let's get started and let's understand the auto scaling stuff. And we have to understand what is auto scaling, what are its different components, and how it's been configured. So let's get started. What is auto scaling? What it is? First of all, we have to understand some of the concepts, the principles, and after that we'll start with the configuration. So the auto scaling is a service that is based on the principle of elasticity. So elasticity is a principle. Elasticity is a principle. So you make use of the auto scaling as a service to apply elasticity in your day-to-day environment. Now, what is elasticity? Elasticity means that you can grow or shrink your entire infrastructure based upon the patterns of the incoming traffic, time of day, or the demand. I repeat my statement. Elasticity is a principle. It's a concept that helps you to grow or shrink your entire infrastructure based upon the patterns of the incoming traffic, time of day, or the demand. For example, today or in the normal days, during the normal days, you have 20 instances. Okay. Now, on any of these special days, for example, you have advertised some discounts, some bumper discounts on Christmas. So you have a Christmas sale. Okay. During that event or during those days, you may bump up from 20 to 200. And then once the Christmas sale is over, then you just shrink back to the normal size, the normal fleet size. That's the main concept of elasticity. You can grow or shrink your entire infrastructure based upon the patterns of the incoming traffic, time of day, or the demand. That's the crux of it. That's the essence of it. Fine. And auto scaling is the practical application, or I would say it's a practical version of elasticity. Now, let's start with auto scaling over here. So auto scaling has few components. We have to understand those components first, and then we start with the configuration part. So what are the auto scaling components? See, the first component of the auto scaling is the auto scaling group. What is the auto scaling group? The simplest definition I can give you is it is a logical collection of identical EC2 instances. It is a logical collection of identical instances. You group the instances together depending upon the services and applications running upon them. You group your instances together depending upon the applications and services you run upon them. For example, I have two different auto scaling groups. So let's take a very simple example over here to understand this concept. So these are two different groups. This is my ASG auto scaling group 1, and this is my ASG2 auto scaling group 2. It consists of the instances upon which I'm running the WordPress site. And on the other hand, I have the other auto scaling group upon each instance I'm running the Drupal web application. So basically, the main concept behind the auto scaling group is that it's a logical grouping of instances. That's it. You group your instances together depending upon the types of applications and services you run upon them. Depending upon the types of services and applications you run upon them. Fine, it's a logical grouping of the instances. The second component that we are about to discuss is the launch configuration. See, the thing is that auto scaling, which uses the concept of, or it's based upon the principle of the elasticity. It has ability to launch or terminate the instances automatically. So if there's a demand, there's a need, auto scaling can just go ahead and just launch the instances automatically. Now the question releases over here that okay, if the auto scaling has the ability to launch the instances automatically, we agree to that. But how exactly it will have the understanding of the AMI? That what should be the AMI of the instance? What should be the instance type of those instances? What should be the EBS volume settings? What should be the security groups assigned to the instances? What should be the key pair for those instances? What should be the softwares, scripts, applications to be deployed upon instances? This is a big question. If the auto scaling is an automation feature, it has the ability to launch the instances by itself. How on earth it will understand these parameters. It will understand, or it will get to know that these are the parameters it needs to launch the instances. So launch configuration is basically, it is a template. It's a, what is that? It's a template. By template, I mean that the launch configuration will have the ability to just give you the template so that the auto scaling can just refer to this template and decide upon the parameters or the specifications of the instances. So I give a very layman example. You want to cook a dish. You want to prepare a meal, a dish. So this is the first time you want to just cook a dish or prepare something special, and you don't know how to make it, or how to prepare it, or how to cook it. So first of all, what you do is that you just pick up the recipe book. In the recipe book, the first thing that's there on the first page is the ingredients. Before you just know the process to make that particular dish, you have to see that what are the ingredients, the spices, the vegetables that goes into preparing that meal, that dish. Similarly, before the auto scaling can decide upon that, okay, I have to just go ahead and launch the instances, how on earth it will understand that what should be the ingredients, what should be the AMI, the instance type, the EBS volume settings, how much storage needs to be added, what should be the security group need to be added, the key pair, softwares, scripts, applications. So it will refer to the launch configuration. So if I just draw it, auto scaling as a service will refer to the launch configuration to understand all the ingredients or the specifications, and then based upon what's there in the launch configurations, it will just deploy the instances inside the auto scaling group. So it will refer to it. It will just apply the same AMI, instance type, key pair, the firewall, which is the security group, the key pair. It will install the same applications, services, everything upon those instances. So it's a template. It's a template. So you have to have the launch configuration being created before you just configure the auto scaling group. It's important that you have that. It's extremely important that you have this launch configuration. Fine. So it's a template which consists of all the ingredients and the specifications that are needed by the auto scaling to launch the instance inside the auto scaling group. Fine. The third component that we will discuss right now is, we have discussed the auto scaling group, we have discussed the launch configuration. The third one we'll discuss is the scaling policies. The two types of scaling policies we have. One is scale out, and the other one is scale in. What's the difference? See, if you talk about scale out, this means you would like to, you need, or you like the auto scaling, or you want to have auto scaling launch, which means increase the number of instances inside the auto scaling group, or within the auto scaling group. That means scale out. Scale in means that you would like to, or you would like to have the auto scaling as a service to terminate, or I would say decrease, because if it terminates, it will decrease the instances within the auto-scaling group. Now, one thing you have to understand, the auto-scaling will scale out, launch, or scale in, terminate. It will not stop instance. There's no process to stop instance using auto-scaling. Either it scales out, which means it launches, or it scales in, which means it terminates. These are the two processes it follows. These are two different processes, right? Scaling policies, scale out and scale in. The fourth component that we discussed right now is scaling plan. That how exactly you want to scale. The first scaling plan is fixed. Fixed means that you go with the desired capacity, which means that you fix the number of instances, and auto scaling will ensure that it always have the same number of instances to run the application. Fixed scaling plan means that the auto scaling ensures that we have the fixed number of instances up and running to support your application. For example, you fix 5 instances to be running in the auto scaling group. Auto scaling as a service will ensure that it always has not less than 5, not above 5, fixed number of instances up and running to support your application. It's fixed. It will not go below it. It will not go above that number. This is the simplest scaling plan you can go for. The second scaling plan is called the dynamic. The dynamic scaling plan means that depending upon certain thresholds, you have the auto scaling to increase or decrease the number of instances. So, for example, let's take an example. I can say that, let's imagine this is my auto scaling group. And for the auto scaling group, the CPU usage is more than 80%. If that's the case, then initiate the scale out policy, which means we'll need to increase the number of instances. We need to increase the number of instances. Fine. Similarly, not similarly, or the other way around, if for the same auto scaling group, if the CPU usage, the average CPU usage of the entire group is less than 30%, go ahead and initiate a scale in event, which means decrease the number of instances. This is called the dynamic scaling plan. Depending upon the values and thresholds, you have the instances increased or decreased. And the fixed, you fix the number of instances. The third scaling plan is the scheduled actions. Or it's time of day. In the short form, it's TOD. Scheduled actions means that depending upon the time or the date, you either have the scale out event or scale in event. For example, I can say that every day between 10 a.m. to 6 p.m. I should have 10 EC2 instances in my auto scaling group. But after 6 p.m., I generally see a dip or the amount of request coming down or going down. So the volume of traffic eventually goes down after 6 p.m. So I can say that every day from 6 p.m. okay, to 10 a.m. next day. Okay, so from 6 p.m. to 10 a.m. next day, I will need to have only 2 EC2 instances in the same auto scaling group. So depending upon the schedule and the time frame, because from 10 a.m. to 6 p.m. it's a peak time for you. You see a lot of users coming in and browsing your websites and making some purchases. From 6 p.m. to 10 a.m. the next day, you see you don't see a lot of traffic coming in or requests coming in. So you can just go with the 2 instances. So this will eventually decrease your cost. Fine. So you can go with the scheduled actions or time of day. So these are 3 main scaling policies or scaling plans. We can also go with the manual, but we don't use it. These are 3 main scaling plans you can go for. Okay, we have the fixed, dynamic, and scheduled actions. Okay, so these are the different components of the auto scaling right now that we have discussed. These are different components. One is the auto scaling group. Then we have launch configuration, scaling policies, and scaling plans. Right? So these are the different components that we have discussed. Now we shall go ahead and start with the start with the configuration part. Now the configuration part is quite lengthy. What I will do is that I'll just go ahead and open my Evernote checklist. I'll also give you a copy of that checklist. We're going to be using the dynamic scaling policy or the target tracking policy. It's the same thing, to dynamically scale our applications using the target tracking policies. I'll let you know what is a target tracking policy in that process. So we will, I just give you a copy of this list afterwards, or I can just give you right now. So I'll also include that. Let me just copy this. Let me just copy this link and just give it to you. So I was saying that this is there. So you can just check out this link. So this will be included. So this checklist, I'll be just going with this checklist to ensure that we follow the step-by-step procedure to deploy our application, or we can say we can dynamically scale our application using the target tracking policies. So the very first thing we'll do is that we're going to launch an instance using the same script that we used in the load balancer, using the same script that we used in deployment of the classic load balancer, the deployment of the classic load balancer. Now, why I'm going with this first step? See, it's very important that we have to understand the process to deploy the custom AMI. So let me just give you a small, or I would say a brief overview what exactly a custom AMI is and why you need it. So right now, the main thing that we have to understand is the custom AMI or customized AMI. What exactly this thing is? See, the customized AMI is needed in a case where you want to deploy the same services and applications upon instances, whether you launch them manually or you launch them automatically. So what's the process? The first step is that you launch instance, you launch an EC2 instance using a public AMI. Public AMI means that it is there for everyone's use. You can go to the quick start menu and use any of the public AMIs. Then you launch services, applications, softwares, scripts, upon that EC2 instance. That's what you do in the second step. Then in the third step, finally, you capture image. You capture the image. You capture the image. So I just draw it right now. You have this instance. I'll just give you one example. Let's take one example. The example we're taking is that you just take an instance. You launch an EC2 instance using, for example, Amazon Linux AMI, right? Now you install upon it, let's imagine, you install upon it Apache web server plus, let's imagine, MySQL SQL database plus you deploy upon it the WordPress site and you configure it, you customize it. So you customize your WordPress site, you customize it. Okay. Now, once you install everything and you customize everything, then what you do? You issue a command. That command is you just go to the instance and just issue a command, create image. That image will capture this operating system, this Apache web server, the MySQL database, and the customized WordPress site, everything in a single package. From that image, you just deploy the n number of instances with the same operating system, services, applications, database, and the customized WordPress site running upon it or upon them. That's the process and the strategy that you go for. So having the customized AMI is the heart and soul of the automation, because ultimately the instance has to boot up from the AMI. So you encapsulate the softwares, the services, the applications, the operating system as a part of the custom AMI. So you create the image, and what you get as a product, you get a customized or custom AMI. You issue a command, create image, and you get a custom AMI. Now, in my case, what I want to do is that we use these instances. If I just go back to the instances right now, we use these instances as a part of the Classic load balancer, and I use a script. Okay, now I can install anything upon it, but right now I've installed the Apache PHP web application upon instances. It's already been installed. I'll capture the image out of it. So I choose instance, go to actions, go to image, and click on create image. So I issue this command, create image. Let me show you once again. I have the Apache PHP web application running upon the instance. I choose it, choose the instance which already has the operating system and my desired application running upon it. I choose it, go to actions, go to instance state, and the next thing I'll choose, image. I go to image and click create image. I name this image as Apache PHP image. I just copy and paste. So let me just Apache PHP image. Now I just copy and paste the same in the image description. Now, whenever you capture the image from any instance, you capture the image, it will take the snapshot of all the associated volumes of that instance. In my case, it will take the snapshot or the backup of that root volume. I click create image. It says create image request received. I click close. I click close. Then if I just go to the AMIs on the left hand side in my navigation pane, if I just go to AMIs, you will see that right now it has just initiated the process to create my custom AMI. Fine. The custom AMI. And if I show you these snapshots on the left hand side, you can see that the snapshot is also in the process of getting created. So as if now, if I just go back to the same checklist that we were referring to, I can check mark this option. We launched an instance using the script, and then we captured the AMI out of it, because this AMI would be the part of my launch configuration, which is my template. Now, once you capture the image, once you install everything upon it, and you just carve out or capture the image, it's no longer needed. If you want, you can terminate those instances if you want. But as of now, what I will do is I go to my load balancers on the left hand side, go to the instances, and remove both the both instances from the load balancer by clicking on remove from load balancer, because I don't need these instances anymore. It's of no use. So I just want to capture the image. If I want, I can just go ahead and terminate these instances. They're no longer needed. Fine. Because if I use auto scaling will deploy the fresh new instances. Then I go to my notes, and if I want, I can terminate, but I've just removed my instances from the load balancers, from the load balancer domain. In our previous conversation, we already have created and configured the classic load balancer, so that step has been done. So we have already done that. So I will just check mark this option, because we've already created and configured a classic load balancer. Then now comes the configuration part of the auto scaling. And the first thing that we have to do is that we have to create and configure the template, which is the launch configuration. So what I will do is that I just go back on the left hand side. I just shoot back on the left side in the navigation pane, click on auto scaling launch configurations. I click on create launch configurations. Now, if you remember and recall what we discussed in the launch configurations, a launch configuration is nothing but it's a template. In this template, I choose this customized AMI that we just captured before coming to this page. So I choose my Apache PHP image right now, click select. Now I will select the instance type that would be used to launch each and every instance in my auto scaling group. So I'll go with the t2.micro. Click on next configure details at the bottom right hand corner. Then I name this launch configuration as let's name it as my Apache launch. You can just assign any name to it. Fine. And once you assign a name to this launch configuration, then these are the optional values. You don't have to configure them, and you don't have to go to advanced details as of now. So I just go ahead and click on next add storage. Now I will be adding my storage, 8 gig of storage that will be created from the same snapshot. See, we'll discuss the snapshots and the volumes in a different conversation, in a separate discussion. We can create the snapshots we can create the volumes from the snapshot. This is the same snapshot that was created at the time when we captured the image. So all the volumes that would be the part of the instance would be extracted from the same snapshot behind the scenes. I click on next configure security group. I'll pick the same group that would be assigned to all the instances that will be launched in my auto scaling group. So I choose EC2-HA. This one. Click review, click continue, click Create Launch Configuration at the bottom right hand corner, and this creates my template. Now, in the last step, I have to choose that what's the key pair I'll be using to log in to my instances in the future. So I create a new key pair. Let's name it as ASG demo. That's it. I click on download key pair, and this downloads the copy of the private key on my desktop. And I click on create launch configuration, and this creates my launch configuration. Now from this launch configuration, I just create an auto scaling group. Now can you see this option right now? It says create an auto scaling group using this launch configuration. So I just named this launch. I've already created my launch configuration. Now I just create my group through this. So I just name it as Apache ASG, or I would say Apache Auto Scaling Group. Okay. So from this, I'll be using this launch configuration to be applied to this auto scaling group. Then we have the group size. Group size will specify the desired capacity. So I will have 2. This is my desired capacity. So these number of instances should be up and running at any time. I should have at least these many number of instances being up and running. This is the desired capacity, which is being specified by the group size. The next thing that we have to choose is the network. This is my default VPC. I choose both the subnets of my default VPC that are associated to 2 separate AZs. Okay. Then I just go to the advanced details, and now I'll include the load balancer as a part of this entire config. Okay. Now you may be wondering, how come this load balancer is coming in this picture? Does it make any sense? Why you need a load balancer? As of now, we're discussing the auto scanning, but now how come this load balancer is jumping in? See, the thing is that in order to have a complete architecture, you have to configure these components to work hand in hand. So let me just sketch it for you that how exactly the auto scaling fits in with the load balancer. It's very important. So I just draw an architecture for you and help you understand that how exactly these 2 different components work with each other, how they can work with each other. See, let's imagine this is my VPC. So this is my region of Mumbai, and this is my VPC. Now I have the subnets. This is subnet A that belongs to AP South 1A in Mumbai, and I have subnet B that belongs to AP South 1B in Mumbai. What's a subnet? It's a complete block, or it's a complete range of private IPs. Now, what I will do is I'll deploy a load balancer on the top of them, and the load balancer will just distribute the traffic across these instances running in the subnets. These are my EC2 instances. Fine. So users will just type in, for example, xyz.com, my domain. It will be converted to the DNS name of the load balancer, and the load balancer will just load balance this traffic to the instances running in separate subnets or the zones. Now, eventually what I'm trying to do is I'm saying that these 2 different subnets are the part of my auto scaling group. Okay, so what if there's a demand for more instances? I'm just giving one example. Or let's imagine, okay, let's do one thing. Let's imagine that this availability zone goes down. On the left hand side, my availability zone AP South 1A goes down, and all my instances become unavailable. The load balancer will declare them as unhealthy and make them out of service. The problem is that I'm left with only 2 instances. Half of my infrastructure is down. Half of my infrastructure is not available. So auto-scaling group will now refer to the launch configuration. We'll just look into the parameters of the instances, and it will launch 2 healthy instances in the other AZ. And the load balancer, since it's working with the AAG or the auto-scaling group hand in hand, the load balancer will start sending the traffic to the newly launched instances that are being launched by the auto-scaling within the auto-scaling group, because these 2 different subnets are the part of the auto-scaling group. That's how these 2 different components, they fit with each other. If anything goes down, or there's a new instance that's been launched for any reason, maybe the previous instance was unhealthy, or maybe there was a demand for new instances, the load balancer will start diverting the traffic to the new instances. Fine. That's why you go with them. Now the thing is that load balancer. Okay, so there's one thing that's very important. We include one important parameter that's called the health check grace period, which is of 300 seconds by default. Now why go with that? See, the thing is that when these instances are being launched afresh, these two instances are being launched afresh, they will not immediately come in service. You can't expect any instance to come in service immediately after it's been launched. See, the thing is that auto-scaling will trigger the scale-out event to launch the instances. But the instances will take their own time to install the operating system, services, applications upon them. In the meantime, if the load balancer performs a health check, they will be declared as unhealthy by mistake, because they will not respond. They're still booting up. So we'll allow the new instances to boot up for next 5 minutes by default, so that we just give them a grace period of 300 seconds, so that in those 300 seconds they can boot up and become in service. So that by mistake the load balancer doesn't declare them as unhealthy. So I choose this thing under advanced details. Load balancing, I go with the load balancing. I choose receive traffic from one or more load balancers, and I choose my classic load balancer. Target groups will not come in this picture because target groups are relevant to the application load balancer. We're going with the classic one. So this is the classic load balancer that we've pre-configured. We want the instances that are the part of the auto-scaling group receive the traffic from this load balancer. Health check type are of 2 types, ELB and EC2. What's the difference? So it's very important that you understand the differences right now. If you go with there are 2 types of health checks. So what are the health check types? One is ELB and other is EC2. What's the difference? If you go with the ELB health check type, then it will take into account the ELB health checks. Okay. For ELB health check, we know how it performs the health checks. Plus, it will go with the EC2 health checks. EC2 also performs its internal health checks because, for example, let's suppose, I'm just giving an example. If an instance is impaired, it's unhealthy. An impaired instance is unhealthy. So if you go with the ELB health checks, it performs it takes into account the load balancer's health checks plus the instance health checks. So any impaired instance is unhealthy. But if you go with the other health check, that's the EC2 health check, in that case, it will only check the EC2 health checks only. It will just go with the EC2 health checks only. You will not get the benefit of both. You will not get the benefit of both. I would say it is EC2 health check, or I would say it's EC2 status checks. Based upon that, it will determine the health of the instance. So if you go with the EC2 health check, it go with the EC2 status checks only. Okay. So to get the benefit of both, you go with the ELB health check, because in that case, you get both the benefits. You get the benefits of the load balancer health checks and the instance status checks, both. But if you go with the EC2 health check, then the health of the instance is determined by the EC2 status checks only. I've given an example. If an instance is impaired, it is unhealthy. If it's running, for example, it is running, then it is healthy. Okay. So let's do one thing. Let's go back. And I go with the health check type as ELB to get the benefits of both the load balancer and EC2 status checks. Health check grace period is 300 seconds by default. I've discussed with you. Instance protection. I can choose this option to give the immunity to my instance, protect from scaling. What do you mean by protect from scaling? If I choose this option, in that case, none of my instances will be terminated. So I give the immunity to every instance. As of now, I'm gonna uncheck this option. Service linked role. Now this will create a role for the auto scaling to work with the load balancer and CloudWatch, because the CloudWatch will work. The CloudWatch configuration will come just after that. Okay, so this is the create auto scaling group, and this creates a role automatically so that the auto scaling can work with different services like load balancer, CloudWatch. So the CloudWatch will come just after this page. Now we click on the next step. That's the configure scaling policies. Now this is where the real action begins. This is where the exact stuff or exact things work over here. There are two type of scaling plans you can see over here. Keep this group at its initial size. This is the fixed scaling plan. Remember we discussed about this thing. If I just go back to the notes, we discussed about this fixed scaling plan. This one, this means that you stick to the fixed number of instances. If I choose this option, keep this group at its initial size, then in that case, it fixes the number of instances depending upon the desired capacity I've chosen in the previous window. For example, if I go to the previous, can you see the group size? 2. This is the desired capacity. What is this? This is the desired capacity. So if I just go to the configure scaling policies and choose this scaling plan, keep this group at its initial size, then it sticks to the desired capacity. It will ensure that we always have 2 health instances to be the part of the auto scaling group. It will never go above it. It will never go below that. If you want to go in detailed way, you just go with the target tracking policy, which comes under the dynamic scaling plan. If you remember, we discussed that what's a dynamic scaling plan? You scale out or you scale in depending upon the thresholds. For example, if the average CPU usage of the entire auto scaling group is more than 80%, we want to scale out. If it's less than 30%, we want to scale in. Fine, we discussed that. So in that direction, we understand, or we will discuss about the target tracking policy, which is a part of the dynamic scaling. So let's understand that concept so that we understand exactly that how this works for us. So the concept we'll discuss right now is the target tracking policy. What happens in the target tracking policy is that, for example, this is my, I'm just taking one example right now. Let's suppose this is my auto scaling group. Right, so let's go with these are my instances in my auto scaling group. Fine. And to monitor its performance, I use CloudWatch. Okay. Now, in the CloudWatch, I choose a metric. Metric is a parameter against which you want to analyze the performance of a resource. Metric is CPU utilization. CPU utilization. Now the thing is, for this thing or for the auto scaling group, the target value for this metric is 70%. Or I would say, let's remove this. So this is my metric that I configure in my CloudWatch, and for this, the target value is equal to 70%. So I'm saying that for this auto scaling group, so the CloudWatch will monitor the performance of the auto scaling group and shows that the CPU utilization of the entire group is up to 70%, not more than that. Okay. Now, because of the increased number of processes and load, let's suppose the CPU has breached and gone up to 90%. It has gone up to 90%. So let's imagine, because of the number of processes and the traffic coming in, the CPU has increased more than 90%. So it's been breached. It's been breached, right? What happens next? The CloudWatch will send an alert to, and also it can send an email to you as well. You will just also receive an email. It will send an alert to the auto scaling as a service that the CPU is more than 90% now. It has been breached. Auto scaling will trigger a scale out policy. And for example, previously there were 3 instances, now there will be 5. It will increase the number of instances in the same auto scaling group. It will launch more instances. Fine. So you understand this process. The target tracking policy means that it keeps an eye on its target and tracks it. So in this case, the metric is CPU utilization. Okay, and the target value we have set is 70%. If it's been breached, so the CloudWatch ensures that the CPU usage of the entire auto scaling group on an average doesn't cross 70. If that's the case, it sends an alert to the auto scaling as a service. Auto scaling refers to launch configuration as a template and issues a scale out policy or event. It's a scale out event to launch more instances, similar instances in the same auto-scaling group. Fine. So this is the essence or the crux of the target tracking policy. And if the CPU goes down, it has the ability to decrease the number of instances. Now let's do one thing. We start configuring the target tracking policy by choosing this option, use scaling policies to adjust the capacity of this group. So I choose between 2 to 10. So 2 is the minimum number and 10 is the maximum number. 2 is the minimum number and 10 is the maximum number. Then this is the name of the scaling policy or the scaling plan. And these are the 4 different metrics. Application load balancer request count per target, average CPU utilization, average packets in, average packets out. I go with the average CPU utilization. Let's go with that. Target value is set as 70%. This is the warm-up value or period. This means that we allow the instances to warm up for 300 seconds once they get launched. It's the amount of time that instances need to warm up, because as soon as you launch the instances, you can't expect those instances to be in service immediately. They can't contribute to the metrics of the auto scaling. So we give this time for the instances to boot up before they contribute as a part of the metrics. I can disable the scale in so that auto scaling will not be able to terminate any of the instances, but as of now, I'm going to uncheck it. So that's how we configure the target tracking policy. I set the minimum size, the maximum size. So it will oscillate between 2 and 10 number of instances. The metric type is average CPU usage, value 70%, 300 seconds for the instances to warm up. Fine. I click on configure notifications. Now I add the notification and click on create topic. This is the SNS topic. That stands for simple notification service topic. That will shoot up the notifications if any of these events occur in my auto scaling group. If the instances launch, they terminate, they fail to launch, they fail to terminate, then I should be notified. So I just name it as notification, or I would say notifications to my inbox. That's the name of the SNS topic, and I specify my email so that I should be sent the notifications to my this email address. So in the meantime, I just open my inbox, and that's it. I can add more notifications if I want, but as of now, I just go with only one notification. I click on next configure tags at the bottom right hand corner, and can you see that I just received this email? I think this is not the one. Let's see that, because we have to see. I don't think this is the one. This may be from the previous configuration. I'll show you. So I click on configure tags. I can add a key and the value for this group. It's optional. I click review. I can just review any of these parameters before I click create. I click create auto scaling group, and this creates my auto scaling group from scratch. And immediately, so I just click on view your auto scaling groups, and it will launch 2 instances. In the meantime, I go to notifications, and I can just click on confirm subscription so that I can just confirm my subscription to the SNS topic so that I receive the alerts and email in the future. Fine. So as of now, if I just go to the instances, you will see that it has just launched 2 health instances from scratch. And these 2 instances, if I go to the load balancers, they will start reporting or registering themselves to the load balancer. And can you see that I've started receiving these alerts? This alert is for the instance launch. So if I just go to the instances, you will see that these two instances are immediately in service with respect to the load balancer. And if I just go to description, copy this DNS name of my load balancer and paste it, you can see my application is up and running immediately. So the autoscaling automatically picked the minimum number of instances, refer to the launch configuration, launch my instances with the same script, application, services, instance type, AMI, everything. And here we go. Fine. So it launched 2 healthy instances. Now let's do one thing. Let's do some disruptions. I will intentionally bump up the CPU usage of both instances so that the average CPU utilization of my auto-scaling group, it increases above 70%. Let's do that. I go to my instances right now. In the meantime, I just go back to my downloads, and I drag and drop my PM key, okay, to my desktop. And let me rename it so that it can be in .pem format. I open my terminal. Let's do that. Let me just open my terminal real quick. And let me just close this one out. Let me open a new terminal window. And I go to my desktop. And let me see the name of the key, ESG demo. Okay. So I need to change the access rights because I'm using Mac OS. So I have to change the access rights. Sorry. Done. Then I initiate the SSH connection to the instance, to one of the instances right now. So this instance that it just launched, this instance, it just launched this instance, this one. Okay. Let me just terminate the previous instances. I don't need them to avoid any confusion. Okay. So we just let me label these new instances that have been launched by my autoscaling as A and B. Okay, so if I filter my instance A, okay, let me just do one thing. Let me just name it as instance A, and this is my instance B. So these are the 2 fresh instances launched by my auto scaling group. I've just terminated the instances that we launched in our load balancer configuration. Fine. So let me just name it at instance A so that we can just filter them. Instance B. Fine. So I go to instance A and copy its public IP. Paste it. So just log in real quick. I need to ensure that I allow the SSH from my IP. So I'm going to just go to the security group and allow the SSH from my IP real quick. So let me just press Ctrl-Z and rerun this thing. Connect it. Then I run 2 commands to bump up the CPU usage of this instance. Sudo yum install stress. Okay, these are 2 commands. This is 1 command. Let me just correct it. Sudo yum install stress. Let me just correct this command. Sudo yum. Just hang on one second over here. Install stress. It just downloads a stress package. I dispatch some hogs. Stress -c space 5. It will dispatch the hogs to bump up the CPU usage of this instance. Similarly, I'll just initiate a new connection to my other instance right now. New connection. Let me just go to the desktop. And if I see if I can just copy and paste the command from here. And just go to the instances right now and just mention the public IP address of my second instance. Right, so I just run the same command, sudo yum install stress, install the stress package, and stress -c 5. Done. So as you can see that it will dispatch the hogs. Within next 3 to 4 minutes or 5 minutes, I'll see the CPU usage of both instances to bump up, and as a consequence it will just launch more instances. So we have to resume for next 5 minutes. I would say we have to stop for next 5 minutes and see for the output to come to show up. Because if I just go to the instance right now, go to the monitoring, and I will eventually see the CPU going up of both instances. So let's wait for a few minutes over here. So if we just go back to the notes, if you just go back to the same notes right now, so we create the launch configuration, we create the auto-scaling group, we configure the target tracking policy, notifications, tags, we created the auto-scaling group, we have confirmed the subscription of the SNS topic, and we have tested our scaling policy. Fine. So now let's do one thing. Let's see the CPU usage of instance A. And as you can see, for instance A, it has gone up to 100%. And if it is go for instance B, it has touched up to 100%. Fine. Now, if I just remove the filters, you will see that it has just launched 2 healthy instances. Just launched. Can you see that? Just launched 2 healthy instances. And if I just go to the auto scaling groups right now, and I just go to the instances, you will see that not 2, it launched 3 instances. 3 instances. 2 the one that were the previous instances, it launched 2 healthy instances. And if I show you the activity history, you can see that these are the instances it just launched. If I go to any of the instance launching activity, I can see a cause of it. What's the cause? What's the why this was initiated? At this time and date, an alarm was triggered. This is the alarm, and it increased the desired capacity from 2 to 3. Hence, in that case, it launched a single instance. Then when it saw that the CPU utilization is above 90% or 100%, it has to launch more instances to bring down instances. It has to launch more instances to bring down the value below 70%. Then it launched 2 more instances. And we'll keep on doing that until and unless the CPU of the entire group comes below 70%. Now, I'll do one thing to just make sure it doesn't launch more instances. I can just press Ctrl+Z to just terminate this process. Okay. So this is all about the auto scaling target tracking policy. So what we discussed over here, we discussed that how you dynamically scale your applications using the target tracking policies. Now, one thing that's very important, once you perform the lab session, delete your auto scaling group. Don't terminate the instance manually or straight away don't terminate the instance, because if you terminate an instance, autoscaling will launch a new instance to compensate for it. So as a process of cleaning up, once you're through with the entire process, you choose the autoscaling group, go to actions and hit delete. It will delete this group plus the instances. You don't have to delete the template, that's the launch configuration. Why? Because launch configuration is just a template. You can have hundreds of templates and you don't have to pay even a single penny for it. Okay, but for the autoscaling group, it's a free service, but you pay based upon the number of hours consumed by the instances. So once you're through with the entire lab session, go to actions and click delete. Okay, that's all about the configuration of or I would say, dynamically scaling your application using target tracking policies. I will include the script as well so that you can just go ahead and practice on your own, and as well as this checklist.